Teaching techniques. When doing this topic, I would always use actual physical nets. I'd have them cut out of cards so that students can fold them up and see whether they will form a cube or not. I would get them to arrange the ones that will and won't and see if they can come up with various similarities or a pattern or anything that connects the ones that will compared to the ones that won't. For example, I would expect them to find that each net that does form a cube has 6 squares and a perimeter of 14 squares. I'd expect them to find out that if you only have squares in one row, it won't work. It's no use having 5 or 6 squares in a line because they won't fold up to make the tops and bottoms. The longest line of squares they should be able to find can only be 2 or 3 or 4. There are several with 4, however. Through doing this kind of investigation, they should be able to start to recognise the ones that will fold up and the ones that won't, and their different properties. As you can see from this example, as there are no squares to fold down to create the sides, this net will not form a cube. Deep thinking. To further extend the students' understanding of what nets are, I would present them with other possible 3D shapes and their nets, and see if they can explain why certain ones join up to their nets. For example, they may notice that the cylinder is made up of 2 circles, and then they should know that this section is made up of a rectangle when it is unravelled. That therefore suggests that it would join up with this one, as this is made of a rectangle and 2 circles. This is different to the cone, which is made up of 1 circle, and then something that forms the cone shape, which must be this one. Again, you may want to give them actual nets and get them to fold them up to work out which ones they go with, and explain why they've identified that they go with those 3D shapes. On the other hand, they could work out why the 3D shape goes with a net, using different 3D shape properties, or they may want to describe the properties of the net itself.